Okay, so now it's about we're going to do AMath today. So we're going to do AMath quadratic inequality. This is a topic. Hi, this is a topic that is requested by some student. I don't know who one of the live, few of you all requested for it, so I'm doing it now. Okay, so let's start the topic. Okay, so this is about quadratic inequality. So first of all, before I do AMath quadratic inequality, let me talk about the AMath linear inequality. Okay, it's like, for example, our equation, we have linear equation, then we have quadratic equation, correct? So inequality also the same thing. We have linear inequality and we also have quadratic inequality. It's just that quadratic inequality is only learned in AMath. It's not learned in AMath O level. So let's talk a bit about the inequality. Okay. So when we have inequality like simple linear inequality, of course I'm going to make it very simple here. So when we have 2x, let's say equals, I want to talk about inequality, I go and write equal. Let's say I have less than 3x plus 4. This is linear inequality. This is linear inequality. Okay, you can see that it's x to the power 1, x to the power 1. So I want to solve this, right? So it's the same concept as solving linear equation. I'm going to bring all the x to the left hand side. So we have 2x minus 3x less than 4. We have minus x less than 4. Okay, then you see I have a minus x, right? So what we're going to do is divide by negative 1. So take note about linear inequality inequality. When you divide by negative number, you need to flip the mouth. Okay, because if it's linear equation, doesn't matter what you see. Linear equation, when you write x equals to 4 or when you write 4 equals to x, it doesn't matter. X equals to 4 and 4 equals to x is the same, whereas in the equation. But for linear equality, it matters. Okay, whether is it x more than 4 or whether is it 4 more than x, it matters. It's two different things. The top one represent that the x is more than 4. That means like 5, 6, 7, 8. But the bottom one is x less than 4, which is a 3, 2, 1, 0. So it matters which side you put for inequality. So in this case, when we divide by negative, you need to flip the mouth. Okay, this is one rule about inequality. This is one very important rule about inequality. So when I divide by negative 1, I need to flip my mouth, and this one become 4 divided by negative 1. So x is more than negative 4. Right, so this is a basic of inequality. Basic. Okay, then after that, now in AMath we have quadratic equality. Okay, so let me get one quadratic so that I can give you an example. Okay, let's say for example I have, now we talk about quadratic inequality. Okay, and this is only in AMath. AMath don't learn quadratic inequality. AMath don't learn. So example I have, let's say, okay, they say x squared plus 5x minus 14. Okay, they say more than 0. So you see, more than 0 means we know that it is an inequality. Next, you identify whether is it linear inequality or is it quadratic inequality. So because it's x squared, so you know it's quadratic equality. So similar like quadratic equation, when you are solving quadratic equation, you throw everything to the left hand side and right hand side 0, right? So same apply for quadratic equality. So everything throw to the left hand side, for this case already throw. So all I need to do is you factorize the left hand side. So this one we will use cross method to factorize, right? So you will have x squared minus 14 plus 5x, x and x, and then we have minus 2 and positive 7. So we have here plus 7x, here is minus 2x, check. So this side, when I add them together, I get positive 5x, minus 2 times positive 7 is negative 14, x times x is x squared. So then we know, so this one will be 2 bracket more than 0, x minus 2, as well as x plus 7. Then the next thing is, you got to draw the diagram. Okay, draw the diagram. And for me is, I always make it a happy face. this is anyway the x squared, the coefficient is 1, a is more than 0, is a happy face. So after you draw this, you need to put what is the two values here. So this two value is just like as if you are solving the quadratic equation, and what are the two roots. So in this case, we know that x minus 2 equals to 0, which is x equals to 2. And x plus 7 equals to 0, it means that x equals to negative 7. So I will put minus 7 here and 2 here. So then after that, you look at the mouth, this is more than 0. More than 0, okay, this horizontal line that I'm drawing is actually your so-called x-axis, your x-axis. So when more than 0 means it's above the x-axis, means it's more than 0 above. So if it's above, I want you to shade these two corners. Okay, shade these two corners. And what does this shade these two corners means? If I draw the equivalent number line, it actually means this way. Okay, it actually means this. Okay, wait, I need to tear this out. Okay, it actually means this. So, it means that, so to solve this quadratic equality, it should be x is less than negative 7 or x is more than 2. So this is how you solve quadratic inequality, okay? Then now I'm going to change something. So if let's say I come to here, let's say our inequality, I change the mouth. So they ask me to solve x squared plus 5x minus 14 less than or equals to 0. Example only. So you see that, it's the same thing throw to the left hand side, and when I factorize, I have x minus 2, x plus 7 less than equals to 0. Correct? And same thing, you draw the diagram, and the two value is still minus 7 and 2. The only difference is this time around it is less than 0, means below the the number line method. Actually, number line method is not the one that is shown. This is the one that you should do for your working. But a lot of students do not understand how this graph looks like. So actually, the equivalent is this number line. So yes, do not do this number line thing. So when you draw the working, you should be using the graph. Okay, so this one is below the x-axis. So if it's below the x-axis, means it's here. So it's in between. So in other words, actually when you're solving quadratic equality, actually there's only two regions for you to shape. It's either the blue color one, which will end up having this, or the in-between one. And this in-between one means it is x is between minus 7 and 2. And do I have to put the equal? Yes, because this itself has the equal. So I put the equal. So basically you only have two conditions, right? You either shade outside or shade inside. You understand? Yes, below the x-axis. Okay? Then the next thing is I want to also, when is it N shape? About to say that I hate socialites, okay? I don't like N shape. Okay, N shape means it's set face, right? I don't like. Okay, so now I'm going to talk about something. So let's say this question over here. You see, if I change a bit. So if this question is minus x squared minus 5x plus 14, let's say it is more than 0. So we look at it. Okay, it's an inequality. Then x squared, so I know it's a quadratic inequality. Okay, so quadratic inequality. Then the next thing is, we know we need to throw everything to the left hand side, right? So it's done already. But the sad thing is, it is a set face because my coefficient of x squared is negative 1. So some students very powerful. They solve. They can give me this one. Okay, no, don't do that. Okay, we don't like to have set face. So actually, all you need to do is, I should use Spencer just now. Okay, all you need to do is change it to happy face. So how do you change it to happy face? Very easy. Take note, very easy. Just multiply by negative 1 throughout. Inequality is the same thing like equation. You can multiply a constant throughout. The only thing that you need to take note is when I now multiply by negative, I need to flip my mouth. So I times negative 1 throughout. Negative x squared become positive x squared. Minus 5x become plus 5x. Plus 14 become minus 14. Then I need to flip my mouth. Then you see, it become a happy face. Then you still do the same thing by factorizing. So you still have x minus 2 and x plus 7. And after that, same thing, you draw the diagram. and you have minus 7 and 2, and less than 0 means it's here. So that means x is between minus 7 and 2. Done. You see that? So my quadratic inequality, okay, let me just say that basically there are only 3 situations. If it's a sad face, you need to do one extra step, multiply by -1 to make it happy face. Then make sure you change the mouth. Okay, so once that is settled, you only have 2 scenarios whereby you either shape the corner, which is above the x-axis, or you shape the in-between. No other scenario, you understand? So this is the basic of quadratic inequality. Okay? All good? Yes, important to draw the graph. My student, okay, I can say 10 times, sometimes they just, wow, you know what they do? They thought that, oh, they can imagine their head or whatsoever, then after in the end their range is wrong. So the common mistake that students always make is, after they have these two, let's say for example let's say this number, then they super love to do what, you know? They say, oh, my x minus 7 more than 0, or my x plus 2 more than 0. Who always do this? I can tell you 9 out of 10 students always do that. But please, it's not this, okay? This is not how you solve quadratic inequality. So this is definitely wrong. You understand? Wrong. After you do this, no need to think so much. Draw the diagram. Put in the 2 numbers. The 2 number is just as if you are solving the quadratic equation. So you have minus 2. You have 7. More than 0. Just now I already teach above. So shape the corner. It means x is less than -2 or x is more than 7. Done. You understand? Okay. So please don't make this kind of mistake. Please don't make this kind of mistake. Once you have this, factorize, get the 2 values. Then after that, shape either the corner or shape the in-between. That's it. Okay. Let me see. Cher, you know how to do the product and roots? Yes, I do know how to do the product and roots and sum of roots, but that one it's no longer in O-level syllabus. They took it out from the syllabus. Okay. Yes, they took it out. Yes, so I hate socialize. Yes, that's a common mistake that students always make. So now you know. Okay, then let's see. Why do you have to take the Igcse exam? Challenge myself. No lah. As in like previously when I was in year 2012, I took private candidate O-level. Then of course I already get my A1 for both lah. So then after that, I've been teaching secondary school math tuition for past 11 years. Okay, so now I just want to challenge myself. Okay, I'm curious to know what is Igcse syllabus. Okay, so I take the exam. Maybe I can consider to also teach Igcse math as well, but of course not so soon. After I finish my exam, then after that, then I can consider. But of course I need a proper cert, right? So I will have to take the Igcse exam. Okay. I don't know my Igcse. Oh, the exam result will only be out in November. I still have paper 2 that I haven't do. I only take my paper 1. Paper 2 is next week. Okay, no other chit chat, please. You all want to know each other, please go and talk outside. Okay, teacher can teach P6 geometry. I only teach Sec 1 to Sec 5. I don't teach primary school topic. Can you please write your answer in set notation? It's out of the topic today. Okay, so let's start our question. Okay, thank you. Okay, yes. So wait. Okay, let's start. Okay, I already spent 22 minutes talking about the basic of quadratic inequality. I have no time to chit-chat already other questions. Okay, and I just now also talked about Igcse already, so I'm not talking about it. So before I start, okay, I'm going to talk. Those who are new here, please remember to follow me so that you can get live, as in notification when I go live. Okay, next is also those who are new, go to my bio, click on the link. Okay, the very last button is go to my Telegram channel. So the question in PDF, okay, plus the solution, and also will be uploaded to the Telegram channel tomorrow. Okay, not now. So all these PDF or questions are not available yet because I haven't do the working. So once I do the working solution already, then Sam will upload to this is AMath. Sam will upload to the Telegram channel, okay? Then my link, the second last button, it's the one that go to my YouTube channel, okay? Go to my YouTube channel whereby you can see a lot of videos whereby I teach my past TikTok live are also uploaded there. So like for those students who actually like came in here, or you want to do why Bob is muted? I think what he's trying to say is, Bob, if you, I don't know whether she can still hear me or not. Anyway, okay. What I want to say? Alamak, I say what? Okay. Then after that, yes, my YouTube channel, you can see the past TikTok live. Let's say today you missed out this one, or you came in late, or you want to revise together with the PDF. You can go to my YouTube channel tomorrow, okay, view the TikTok replay and revise together with me and attempt the question together. You understand? So this is how you learn. This is how you learn. Okay, so and also not forgetting my link, the very first button is about the June 2022 O-Level crash course. So for those who haven't signed up and interested, you can go and click on the link and find out what are the details and what are the things that are provided. So if you want, you can sign up. So go to my bio, click on the link. The second last button is my YouTube channel. Just click on the link, it will direct you to my YouTube channel, okay? Okay, let's start. So this one, the equation of a curve is blah blah blah. Okay, y equals to something. Okay, you see that it's not the usual one whereby y in terms of x only. You see the m inside, right? So they say find the range of values of m so that the curve lies completely above the x-axis. So whenever they say these, when they say that the curve lies completely above the x-axis, it is actually indirectly trying to tell you that it is always positive. Means your graph is always positive. It means it's above the x-axis. So above the x-axis is something like this. So let's say your graph is something like that. Okay, and what's the two conditions that you need to know is, always when its graph is always positive, first is a happy face. So when it's a happy face, I will know that my A coefficient is more than 0. Next, because it's above the x-axis, means it does not cut the x-axis. If it does not cut the x-axis, means no roots. Yes, well done. So if it's no root, means my discriminant, which is my b squared minus 4ac, is less than 0. Okay? Many students always know, okay, discriminant less than 0, I know. But many of them do not put the condition about the coefficient of x squared, which is important because actually I have two conditions. So actually I have two conditions to fulfill. So let's take a look over here. So you look at here, you see my A, okay, I'm going to write out y equals to mx squared plus m minus 3x plus m. So with this is already arranged nicely. So my A is actually m, my B is m minus 3, and my C is m. Then you look at your A. Because my A is not a fixed number, sometimes when you can see that it is y equals to 2x squared, my A is 2. So my A is 2 already straight away fulfill the first case. Okay, first condition. Then you don't have to bother about it. But you see, now your A is m and the alphabet. So that means I need to consider this inequality as well. So you will say always positive. You have A must be more than 0. You have b squared minus 4ac less than 0. So with this, okay, therefore I will have my m must be more than 0. So my first inequality is m more than 0. Okay, then now let's go and do our discriminant less than 0. So it will be b squared minus 4ac less than 0. Rainbow out. They're just trying to tell you m is a number, that's all. M is a number, constant. That means it's a fixed number. So it is m squared minus 6m plus 9 minus 4m squared less than 0. So I end up having minus 2m squared. Sorry, minus 3, minus 3m squared minus 6m plus 9 less than 0. So you see, okay, this is an inequality. and this is a quadratic inequality, and this is a set face. So remember just how I teach you, when you see a set face, the first thing is you're going to change it to happy face first. And actually in this case, you can see there's a common factor 3 that I can actually divide as well. So the first thing is I'm going to make it a happy face, and also at the same time reduce it. So I divide by minus 3 throughout. Divide by minus 3 throughout. So I have m squared plus 2m minus 3. Flip the mouth, so it becomes this. So now I'm ready. This is a happy face, and this is already a reduced quadratic expression. So now I'm ready to factorize. So you will factorize using our, of course, the cross method. So m squared minus 3 plus 2m. So this one is m and m, 3 and 1. So this one is plus and minus, minus m plus 3m. So I will have m plus 3, m minus 1 more than 0. And remember just now I say, draw the diagram, the graph. So I draw here, put in the two values. I have 1 and negative 3. Negative 3, 1. More than 0, shade where? Shade the corner, right? So shade the corner. So that means m is less than negative 3 or m is more than 1. So common mistake is students say, okay, this is my answer, full stop. But remember, actually I have two conditions, right? I have this and I have this to fulfill. So I need to find the range that fulfill both of the inequality. So in this case, then you have to draw the number line to see better. So it means that I have to draw a number line with 3 numbers. Minus 3, 0, and 1. So minus 3, 0, and 1. So m is more than 0 means I want this. M is less than minus 3 means here and here. And then you can see that, oh, the only range that fulfill both is only this part. Okay, so the actual answer it should be only m more than 1. Done. I can tell you 90% of students stop here and they forgot about this one. Okay, so in this question it's a tricky one. That's why you see it's a 5-mark question. Okay, you have actually 2 sets of inequality, and you need to find the simultaneous and find out what is the common region. And the actual answer for this is only m is more than 1. Okay, take note. Okay, you explain it better than my teacher. I know. Thank you. Okay, let's move on. Okay, next. Given that y equals to ax squared minus 4x plus c is always negative. So give an example of values of a and c which satisfy the condition. So first, y equals to ax squared minus 4x plus c. So this is a quadratic graph function, right? They say that it is always negative. So if it is always negative means what? It means that it is below the x-axis. Okay, below the x-axis. And this time around, what is the 2 conditions that I need to fulfill? First is a set face, so the a is less than 0. The second condition is, again, because it does not cut the x-axis, means no roots, my discriminant is less than 0. So take note, just now you see these 2 questions, the 2 differences, this is always positive, so it is above and it's a happy face. So a more than 0, discriminant less than 0. This is always negative, it is below the x-axis. Both of them, the discriminant is less than 0, but this is a set face. So you can see that the a is less than 0. So by looking at this function, my a is a for this case, my b is negative 4, my c is c for this case. So when I want a less than 0, in this case, it means that one condition is my a must be less than 0. Next is my discriminant, which is my b squared minus 4ac must be less than 0. So I have these 2 conditions to fulfill. Simplify this first. 16 minus 4ac less than 0. Minus 4ac less than negative 16. See, I'm going to divide by negative 2. Negative 4. So it means you need to flip the mouth. So it will be ac more than 4. So my condition is, you see the question, they say give an example of values of a and c which satisfy the condition. So my condition is I want my a to be less than 0. I want a times c to give me more than 4. So let's say example, if I say a is equals to -1, can be anything as long as it's less than 0. So let's say I assume a is -1. Okay, so then I start my so-called -1 into here, right? So -1c, so -1c more than 4. So you have to ask yourself, okay, you can find any c whereby I multiply with -1 will give me anything which is more than 4. So I will assume that it's, let's say, -5 lah, because if I -1 times -4 is still 4, it is not more than 4. So I will let c equals to -5. So -1 times -5 give me +5, which is more than 4. You understand? So it means that this is one set of a and c that fulfill the condition. So I say I let a equals to -1, and then the corresponding will be my c will be equals to -5. This is one set. And you can see that in the answer sheet, they actually have one set, 2 set, 3 set. So they have 1 set, 2 set, and 3 set. As long as your choice of A and C fulfill both of these inequality, they will accept the answer. You understand? Yes. Okay, let's move on. Do you live? I already know. I only do live. No problem, Megan. Okay, I only do live on Wednesday and Sunday. Wednesday 8 to 9 and Sunday 5 to 6. But my Wednesday now is reserved for normal tech. That means I'm teaching normal tech topics. Then only Sunday I teach either E or AMath. Okay, let's move on to the next question. Okay, so again, this is a bit similar, but I choose this question because later you will see why. Later you will see why that I choose this question. Okay, again, find the values of k for which this function is never negative for all real values of x. Actually, they're just being innovative with their English. Never negative, it simply means always positive, right? So when the graph, okay, this one slightly different is because this one never write y equals to the function. Usually when we draw the graph, we will say y equals to something x, right? So this one is to just give you the expression. So it's the same thing. So they are saying our graph is always positive. So always positive, of course, shit, why did I cut? I shouldn't cut. Like that. So always positive means a is more than 0 and discriminant less than 0. No, I don't teach JC math, sorry. Okay, although my student always, can you teach JC math? All my students after graduate from my tuition already, after when they go to JC, they always come back and tell me that they suffer in their JC math. I can't help them, so sad. Okay, so same thing. So I'm going to write out, so it will be 3x squared plus 6x plus k squared more than 0. Okay, this is what they want. So this means is always positive. Okay, and you know that, oh, okay, a is more than 0 and discriminant less than 0. Look at this a. This a is straight away 3, right? It means that my a more than 0 actually is already, because a is equals to 3, so this one is already fulfilled. So if this is already fulfilled, I don't bother about the first condition. So I only focus on my second condition, which is the discriminant less than 0. So we will do b squared minus 4ac, b squared minus 4ac less than 0. So 36 minus 12k squared less than 0. I will have minus 12k squared plus 36 less than 0. Okay, I'm going to reduce this. This is somewhat is a set phase. So I'm going to do that, change it to happy phase plus reducing it. So I'm going to divide by negative 12 throughout. Divide by negative 12 throughout. So I will get k squared minus 3 more than 0. Okay, this is a tricky one. Although it seems like, oh, it's a quadratic inequality, then how to do this one? Okay, so I have changed it to happy phase, and I also flip the mouth already. Now the question is, oh, this is a quadratic inequality. I want to factorize my left hand side. Then you start, but k squared minus 3, how do you factorize? Actually, this one you can use a squared minus b squared. But student ask me, but 3 is not a perfect square. How? Then you can make use of surds. So I will change this to k squared minus square root 3 square. Because square root 3 square is 3, agree not? And this is in the form of a squared minus b squared, right? So it becomes k plus square root 3, k minus square root 3 more than 0. See, I still factorize. It's just that, of course, it's not a nice integer, it's in terms of surds, but it's fine. Okay, next we draw our diagram, right? Draw our diagram. So this time around, the value here will be, one is negative square root 3, one is square root 3. More than 0 is you shade the corner. So therefore, your k is less than minus square root 3, or k is more than square root 3. Done. So the solving inequality is still quite similar. The only things that you notice is this is only two terms. Then how do you solve? HK is fine. We use a squared minus b squared. And again, the b squared is a little bit tricky. Why? Because it's not a perfect square. So I just use square root 3. Okay? Okay. Let's continue. So now they say, find the range of values of x which satisfy both inequality. So this is what I call simultaneous inequality. It means that you need to solve them individually and find a common range that fulfill both. You mean this one? Which one? This one? Oh, okay. My bad. Because this one is always positive. It's never negative. It's always positive. Wait, No, you shouldn't put the equal. Cannot put the equal. Yes, cannot put the equal. Sam, take note. This one got no equal. Thanks for highlighting. Okay, we cannot put equal. You know why? Because equal means that it touched the x-axis. Means you solve the range already. I mean, you have roots, which is not. Okay, always never negative means it's like always positive. Means that it doesn't touch the x-axis. Never negative means 0 or plus, no man. Never negative, it is always positive. Okay, I think I know what you mean. Let me see. Okay, good one. Let's debate. Let's debate. No need to debate. Okay, it say it's never negative means it is it can be 0, it can be more than 0. Okay, I agree. So it means that my function y, it can be more than 0 or it can be equals to 0. So if it's always positive and it touch equals to 0, that means it touch, it can also means that its discriminant is equals to 0, right? So in this case, here, like that, discriminant less than or equals to 0. First is it doesn't touch, means there's no roots. Equals to 0 is when it's tangent, one root. Agree? One root, agree, So in this case, we just put in this, okay? Put in this, Okay? Agree? Yeah, so this is a tricky one, Okay, so Sam, don't change the answer, This one is fine. This is fine. Okay, I'm going to erase it. So this is a tricky one. This is a tricky one, Yeah. Okay, thanks for highlighting, Thanks for highlighting. Okay, so let's move on. Now over here, I'm going to do this range. So it will be 3 minus 2x less than 5. So it's minus 2x less than 5 minus 3. So minus 2x is less than 2. So this inequality, I'm going to divide by negative 2. Okay, if I'm going to divide by negative 2 means I need to flip my mouth. So my x is more than 1. So this is one range. Now we have a second range, which is 2x squared plus 3x less than 2. So we have 2x squared plus 3x minus 2 less than 0. So again, this is happy face. You need to factorize. Okay, factorize, you will get 2x minus 1. You have x plus 2. So draw the diagram. I will have negative 2 and I will have half. So less than 0 means you shade the in-between. So I have my x is between minus 2 and half. Okay? Okay. Then after that, don't stop. You're supposed to find the range that fulfill both. Okay? So we will always draw the number line. This time around with 3 numbers. So I have a negative 2, I have half, I have 1. So let's say more than 1, I have here. So I will draw this direction, right? So this one, second level, I will put it at the top here. So here, this one, and this is in between. This is in between. Did I miss out something? A bit weird, huh? Okay, so this one is here. Like that. Five minus 3, 2. No wonder lah. I find it very weird. Nobody correct me. Can anybody spot the mistake or not? I was thinking, why is it there's no common region? Then I was thinking, if there's no common region, it becomes no solution already. I made a mistake. Can anybody spot the mistake? How? Anyone spot the mistake? Yes, this one is negative 1. 2 divided by negative 2 should be minus 1. So this one is supposed to be minus 1. So I shouldn't have the 1 here. So I should have one more number, which is minus 1. Okay, which is here. So this is minus 1. Here is minus 2. So this one will be this. This one will be here. Agree? Then the common region is this. And the final range is x is between negative 1 and half. Done. All good. Okay, so this is a so-called simultaneous inequality. You solve one range, and then after you need to find a common region that fulfill both range. So for me is I will always draw the diagram out. Okay, one range I put at level 1, one range I put it at level 2, and then after you see what's the common region. So in this case, the common region is here, which is between negative 1 and half. Okay? Okay, let's move on. Okay, this one. Find the range of values of x such that the curve lies above the curve. So a lot of times the students, lies above the curve. A curve above a curve, right? How to do? So this kind actually it's not that complex. They just try and say, this one means 2x minus x squared is above, means it's more than 2x squared plus 17x minus 42. It just means this. So in other words, they're just asking you to solve this inequality. So I'm going to throw everything to the left hand side. So 2x minus x squared, change that. Okay, 2x minus x squared minus 2x squared minus 17x plus 42 more than 0. So I have minus 3x squared minus 15x and plus 42 more than 0. So we know, okay, this is a quadratic equality and this is a set phase. I'm going to make it happy by multiplying by, actually this one is, I can reduce also. So I will choose to divide instead. So let's divide it by negative 3 throughout. So I will have x squared plus 5x minus 14 less than 0. Now it's happy phase already, I can factorize. So after you factorize, you have x minus 2, x plus 7 less than 0. I have my AMath IGCSE on Tuesday. I don't know whether I will take the, I think I will try to take the pure mathematics AMath IGCSE next year, maybe lah, depends. See whether I got time or not. So busy this year. So when I take this math B IGCSE, was like, oh, yeah. So draw our diagram. Put in the numbers, minus 7 and 2, less than 0 is just here. So in the end, the answer is x is between minus 7 and 2. Done. Okay? Okay, let's move on to the next. So actually, this one is, okay, 2 plus 3x, x minus 5 more than 2 plus 3x. Okay, actually this is quite similar to just on the first one. The only difference is this one is in terms of bracket, you need to do your rainbow. Correct? So let's do our rainbow. This one times this one, 2x minus 10 plus 3x squared minus 15x more than 2 plus 3x. Everything throw to the left hand side because this is a quadratic inequality. So I will have 3x squared, let's see, minus 13x minus 10 minus 3x minus 2 more than 0. So I will have 3x squared minus 16x minus 12 more than 0. Okay, this one cannot further simplify already, and it's already happy face, so I don't have to change it to happy face. It's already happy face. Next is I just need to factorize this. So this is just normal quadratic equality, means you need to expand, and then after that open everything, expand already, simplify already, throw everything to the left hand side, then factorize. Okay, so I have x minus 6, 3x plus 2 more than 0. Draw your diagram. So we will have minus 2/3 and 6 more than 0 means that you go in the shade at the corner here. So in the end, my answer is x is less than minus 2/3 or x is more than 6. Okay? Done. What factor? Yes, combine items. Move it over, switch sign, set to 0. Yes, well done. Okay, okay. Okay, let's move on. Okay, the last two questions for the day. Okay, so they say, find the range of values of x for which blah blah blah. Okay, a lot of students always jam at this question. So they are asking you to do this. They ask you to find the range of x that fulfill this range. Then student, the first thing they do is right now, the first thing, they put 0 over 1, right? Then they cross multiply. But the bad news is, when you cross multiply, it becomes 0 times 6x squared, it becomes 0. Then you end up having 0, how to do, right? So actually this one you cannot cross multiply. So this one is you got to use logic, That means first, here listen carefully, you want this whole thing to be negative, right? You want this whole expression to be less than 0. And because my numerator is a positive number, okay, you will say, since 5 is a positive value, it means that in order for this whole thing to be negative, my denominator need to be negative. So therefore, my 6x squared minus 11x minus 35 must be less than 0. Then the whole thing will be less than 0. Agree? So in other words, I only need to focus on finding the x range that fulfill this inequality. You understand? Got it? You get how I do the reasoning, What thing x minus 1? Yes, this question is tricky one, This question is tricky one, Next, factorize this, So we will have 2x minus 7 and we have 3x plus 5 less than 0. Same thing, draw your diagram, put in the numbers. So we have minus 5 over 3. Wait, sorry, my handwriting. So we will have minus 5 over 3. We will have 7 over 2 here. So you end up having x is between minus, usually equality we will put it in mixed number. Put it in mixed number. Yes, this one come out a lot as explanation. Then student always start. So minus 1 and a this is 2/3. 2/3 minus 1 2/3 as well as 3.5. And we are done. Okay? So it means that this will be the X range that will make these true. Okay, let's move on to the next one. This one a little bit tricky. It's the same, a little bit concept as the top one, but there's a tricky part at the student will wonder how to do this one. Okay, I'm going to write out the question. They say they want 7x squared plus 7 minus 14x over 3x squared plus x minus 10 more than 0. Then students say, oh no, this one is not the same as the first part. The first part is straightforward, as in because the numerator is a whole number and it's positive number, in order for the whole thing to be negative, I only need to focus on my denominator to be less than 0. Then I solve as per normal. But this question, numerator got expression, denominator got expression. How to do? Okay, so this part is we have to make use of completing the square. Okay, so I'm going to massage on my numerator first. So my numerator is 7x squared minus 14x plus 7. Or maybe I do it another side. We will come back on this one. So at the side, I'm going to do this 7x squared minus 14x plus 7. Okay, I want to use completing the square to put it in the completing square form. Factorize the numerator. No, don't factorize. Not factorize. I want to do completing the square. So I should take out the 7. So it's x squared minus 2x plus 1. Okay. Next, completing the square. 7 x minus 2 divided by 2 is 1 square minus backside square. My backside is this 1. This one plus 1, bring it down. So I end up having 7 x minus 1 square. Minus 1 plus 1 means 0. So I end up having just 7x minus 1 square. So do you see that I have changed this expression to be 7x minus 1 square? So it means over here, you will say, oh, okay, so that the top becomes 7x minus 1 square over 3x squared plus x minus 10 more than 0. When you change the numerator to be this form, and the very popular expression x minus 1 square is always positive. So you will say, since x minus 1 square is always more than or equals to 0, okay? In other words, the numerator is always a positive number already, agree? So since the numerator is already a positive number, in order for this whole thing to be positive, I have to make sure that my denominator remain as more than 0, agree? So you will say, since the above is more than 0, therefore I want my 3x squared plus x minus 10 to be more than 0. Then it becomes a normal inequality that you need to solve. So it will become 3x minus 5 x plus 2 more than 0. And then you draw your diagram. We have minus 2, we have 1, 2 over 3 more than 0. So it becomes x is less than negative 2 or x is more than 1, 2 over 3. Done. Did I put wrongly? Oh yeah, sorry. This one I just put the other way wrong, but it's correct. Scare me. Okay? Can? Understand this question? So this question is a little bit tricky because of the numerator. So that's why I always say the method of doing completing the square is super important. So this is using completing square, completing the square. Okay, very important. So use the top to prove the bottom will be greater than 0. So use the top to prove the bottom will be greater. No, the top, because when I change it to completing the square, I already know that the top, the numerator, is already positive. So in order to keep the whole expression to be more than 0, because positive divided by positive give you positive 1. Understand? If today this one is less than 0, and I already know my numerator is positive, that means I need my denominator to be less than 0. I factorize the denominator, cross method. No, this is not H2 math. This is O level, this is Sec 3A math under quadratic inequality. Yeah, so we are done with the questions today. Okay, any questions? What by bottom? What thing bottom? Okay, because I want this whole thing to be more than 0, and I have massaged the numerator over here. Okay, I put an arrow. Okay, I have changed the numerator in using completing the square into this form. Okay, after I change this into this form, this becomes the numerator, right? So I want the whole thing to be more than 0, and because the numerator x minus 1 square, this expression is more than or equals to 0. Actually, if you want, you can put a 7 here, it doesn't matter. Okay? So since this is more than or equals to 0, it means that in order for this whole thing to be positive, because positive divided by positive gives me positive, so I know I need my denominator to be positive. Then you will solve this inequality just like quadratic inequality, factorize using cross method. And then because it's more than 0, you shade the corner, then after it will be this range. You mean this one? I will put the equal, you know why? Because if x is 1, 1 minus 1 is 0. 0 squared is still 0. So this expression still can be 0. Agree? But the bottom and top could also be negative. Yes, I agree that negative divided by negative can be positive. But my numerator is in this form. There is no way that my numerator can be a negative value. You understand? My numerator, after putting it into the completing square form, I already know that my numerator can only be positive. So in order for the whole thing to be positive, then I have to make my denominator to be positive. Why is top more than or equals to 0? Because anything square, you see, okay, let me just give you an example. If today my x is negative 2, see, if today I put at the side here, why is it that this is this? Okay, why is this? So let's say my x, assume my x is equals to negative 4. 7 negative 4 minus 1 squared. 7 negative 5 squared. Negative 5, when I square it, it becomes positive, agree? So it becomes 7 times 25. So you see, it's more than 0, agree? Okay, now let's say assume now my x is 5, a positive value. So 7, 5 minus 1 square, it will be 7, 4 square, and it will be 7 times 16. Again, it is positive, agree? Okay, now next, if my x is equals to 1, I will have 7, 1 minus 1 square, the value will be 7 times 0, which is 0. So you see, be it whether my x is negative, or be it my x whether is positive, okay, or be it my x is 1, okay, the smallest value it can get is 0 only. It cannot be negative. Agree? And that is why this expression is more than or equals to 0. Yes, because no matter what you plug in, it will be positive. Because you will square it, So with this concept, okay, okay, so I'm going to just put at the side here. This one can refer behind. Okay, So now I have shown you why is it that this expression is always more than or equal to 0 already, right? Then again, so the numerator can only be positive. So I need my denominator to be positive. Understand? So if the numerator was negative, you will want the... No. If my numerator is negative, I will want my denominator to be negative, because negative divided by negative give me positive. For this case lah, because this side they want it to be the whole thing more than 0 ma. All good. Taylor, you don't disturb lah. I know you are P5. This is not relevant to you. Okay? So if you want to stay in the chat and you want to stay in the channel and listen, you just listen. Don't try to disturb. Understand? I was reading that sign wrong. Oh, this one. Okay, so this question is a little bit tricky. Okay. Then, why numerator cannot be 0? Huh? You see, if let's say my above, not say above cannot be 0 lah. Maybe we can put one more thing, is we can say x zero over something. Okay, let's see. If I have 0 over something, it will be 0. Then it will be more than or equals to 0. But they want it to be more than 0. Agree? They want me to be more. Okay. Okay, I agree to what? Who's this? Let me see. Where is it? Kumaran. Okay, I agree with Kumaran. What did he say? Okay, maybe we will add this one more condition. I agree what he say. Because if my x minus 1, let's say my x is 1. My x is 1 means my top will be 0. 0 divided by anything will be 0. Agree? Then 0 is not more than 0. Because 0 is equal to 0. Agree? So in order to make sure that we have the range, then we will say that we do not accept. Oh, actually we are not going to accept that value also. Okay, Kumaran, you see, Kumaran, you see here. Initially, I wanted to add one more condition by saying x. Okay. I wanted to add one more condition by saying x cannot be 1. So at least I know for sure that we will not have a 0 condition. Agree? But you look at this range. Look at this range. X is negative 2, 1, 2/3. My 1 is in the middle. Agree? So this is already in this range. Do you see that? So my 1 in the first place is not in my solution. So I don't have to worry that it will be 0. Can? So this one is just check. This is only for checking. Understand? Kumara, agree? Agree, But good. I understand what you mean, I agree what you mean. So Kumara is saying that, oh, what if it's a 0? Then it doesn't fulfill more than 0, ma? Yes, okay?